before starting, I must say to apologize that this material is prepared a few minutes ago or a few hours ago. So I'm not a person to this file, but I'm trying to do. I'm trying to do my best for the best result. The content is like this: mission requirements and trajectory and perform plan engine and the conclusion and so on. We've got two mission requirements. 3 people on board, that means manned. And over 100 kilometers of altitude is suborbital. And we extracted the uniqueness from that mission requirements. And vertical takeoff and horizontal landing and methane engine. The ultimate overall should be less than 3G, because that's why we determined that value should be at less than 3G, because the man should be trained minimally for the space tourism for touring.
We have some technical difficulty. Would it be permissible for him to transfer the file? Sorry about that. We ask most of our students to try to submit their papers online so we can get everything tested, but this paper was an exception.
Yes, okay.
Oh, now it's working. Okay.
Good. And next. A vehicle space plane is defined like this. As I commented, VTHL and thrust variable should be in order to make the longitudinal acceleration less than 3G. And TPS, if applicable, with minimum. Guidance equipment with minimum. And for the safety and reliability and reusability, and available by 2008. We should make vehicle by 2008. The prelim design procedure is like this. These are done, but partly outsourced by the infrastructures in Korea, such as academic universities and government researchers. And next, aerodynamic analysis was done. So far, we are basically determined all the CD and CL and CM versus angle of attack for the L4 wings fuselage are by CFD. A wind tunnel test should be made because the CFD results are not fully estimate the real results. So we should wind tunnel test. So we are making a plan to test that model in the real time from this year. And here the characteristics of a space plane are as follows: oval length and maximum diameter, ring area, incidence angle, swept angle. As you can see, the ring area is somewhat very large because we should vertically we should make that vehicle that is able to land horizontally on the runway. So we have to confront with some difficulties, technological difficulties when liftoff. So that means we thought that that would make a lot of a lot of drags during a boost off. Okay. Next, we trajectory analysis. The trajectory analysis we conducted is based on 3 degree of freedom calculations. The dynamic pressure is just to less than 20 kilopascal, and mainly on CD we determine the coefficients, and the flight path was calculated, and acceleration limit is less than 3g less than 3g, and it was kept during calculation. So we have two kinds of limitations for the calculations: 3g and 20 kilopascal of dynamic pressure. Engine burning time is calculated by trajectory analysis, and proton integration weight were done. Throttling depth is 60% and up to 105%. 60% is mainly on the acceleration limit, based on the acceleration limit. And this was done without any re-entry calculations, and aerodynamic analysis and trajectory analysis are based on the vehicle configuration for the landing. And you can see the profile on the right side. This can be similar to some of that of others. And next, that analysis results shows that initial acceleration is limited to 1.2, and also gross lift of weight is 750 kilogram. Okay, and payload mass 280 kilogram means that the 3 people's weight. And next, weight estimation was done by the Russian specialists. It was verified by them, but we first because we had no previous that, that kind of flight. So we did this calculation, and we are verified by them. It was very conservative, and so it has some room to change that. Next. And the engine prototype with budget was done, and totally less than 200 kilograms. We specifically 198 kilograms was used for the calculation. And other features, re-entry method was not determined yet, but we are prefer to make tilting the main wing for deceleration, because that can they can make the ballistic coefficient down, and less aerodynamically hit by speed braking effect. But we don't rule out the usage of TPS, thermal protection system, because it is very relatively safe and heavy, but it's very expensive. So we'd like to, we don't prefer that. And trim while standing point of view is initial acceleration should be down, so that gravitational aerodynamic losses should be up. Would be up. But we can trim condition while boost up. And the initial engine throttling is in need. That means less slow. Landing properties are made. Are the rate of descent, and landing speed, and angle of attack, and landing gear, weight, and so on are being considered. And static stabilities is longitudinal and directional lateral stabilities are made, but the dynamic stabilities are not determined and calculated yet. Next. I've got some. Our engine is a gas generator cycle, and so it's open cycle. And the engine is like this. This is general view of the engine, and here some controllers and gas generators and servo belts and the torque pumps and very highly reliable combustion exhaust chamber, which was tested over 200 times for 6 or 7 years. So the demonstrated engine was almost developed. So mechanical thrust mixture ratio controller and regulator was utilized. So it can. So we expect that it can make the reliability up. And the TP torque pump with gas generator was not incorporated to be tested, but this year TP with gas generator will be tested to 2006, and multi-ignitable is not available, but for the first time we made a demonstration for the multi-irritable ability, because it can be upper stages, it can be used for the upper stage and expandable to other space missions. And on the right side, you can see the 1D power balanced calculation results. This based on the nominal point and applying fuel-rich gas generator parameters tested. And regenerative cooled by methane, and that was very successful. And the nozzle expansion ratio is at present 16.5. Yes, next. And here we can see the calculation. We can see the results of calculation by its balance equation, and the theoretical ISPs and expansion ratio and expansion ratio as well. Okay then. Here we've got some prototypes for the test, and it was tested for 2 years in the test facilities on the right side. And we've got some flow visualization results and some very parametrically study was done and was tested by PIV and so on. And here, below pictures, you can see the second one is pump, is for the pump, and third one is for the turbine, and the fourth one is fully tested. And here we can say that we have a successful test results at the turbine driver 2, and we had also still dynamical analysis and seal tests. Next page. And ecology, safety, reliability, economy, reusability points. Here we are using the environmentally friendly propellants such as methane. So it should be satisfied for the present law in Korea also. And safety and reliability making much of the rocket engine. Performance is down, and penalties for safety and reliability. We should confront with penalties for safety and reliability. So we solve the problem with the performances down. And the mechanical type of regulation and controlling devices are developed outside Korea, and it will be used for the real engine. And so and we expect it will increase relatively level. And economically, LNG or methane is so cheap, and so it has usability. Here, you can see some hooks by methane at the initial stages of combustion chamber tests in 1997, but now we have no hooks in there. Thrust chamber was tested over 200 times as before documented. In addition, downside model 0.1 ton. That means 1,000 Newton. 1,000 Newton thrust is being tested over 2,200 seconds at once. At one test time. And next. Conclusions. Somewhat digressed, but I'd like to have a conclusion that preliminary design works are conducted and introduced, and engine is feasible enough, and developments of the demonstrator engine are getting to the end for flight. So we can be partly private and government funded at present, and from now on we can also fully funded in Korea. If we can find a space plane developer, because we are the engine company, so we don't have another very specific and very specialties in designing of space planes. So we are looking for space plane development. Actually, of course, in Korea we have a lot of plane developers, but it has some problem because they are making a consortium for each project. So we need a turnkey-based airplane developer. We need. And next. In the future, a dynamically stabilized airplane should be devised and optimized to cope with the changes on the development. More compatibility and safety reliability are desired, and that's if they are satisfied, we can make a full engine that will be tested since this year. And next. And here final test film, but it was
perhaps I could hold it up, show it towards the audience. Can you restart the film? Let's see, let's maybe do it twice, once for this side of the room. Just step it down. Is it working?
Is it? Let's see.
Yes, have a seat.
Yeah, I'm here. Is this guy with sworn name? I'm when you fit a set or.
That's right. Have a seat.
Is he here yet?
I'm here, Don.
Oh, there you are.
All right. Shall we replay it now? This is going this way. All right, let everyone see it.
the film was made in
Yeah, I said it was on television.
Yes. The engine's back tonight, so everyone see that.
At the Los Angeles, at the television radio, they had a football. What?
All right, there you go. The engine's there. Okay, thank you very much.
Thank you for attention.
Are there any questions for? Yes, Mr. Wu.
Do you have the funding you need to go all the way through building and flying the first station?
Yes, we can privately fund it. And now we are fully funded, but in the near future we should make a lot of money. We should raise a lot of money in order to make the Swiss plane. We are thinking of $3,000, $30 million, right? So,
That's what you need
yes.
to go out to fly.
Yes.
But you don't have it in hand.
Yes.
You do.
The vehicle is proposing weighs about 2 tons dry, and so it's about a reasonable amount of money. Any further questions? Well, I really want to thank you very much.